Hello students, welcome back to my new YouTube channel Physics Sketch D.N.Thatoi. In the previous video, that is combination of capacitors, we have discussed all these type of problems. Now in video 2, so we are going to discuss the new set of problems and many more. I hope you will enjoy it. So now please let us recall the problems what we have discussed in video 1. Now these are the combination of capacitors. These are the combination of capacitors. This is the parallel plate combination where C is equal to C1 plus C2 plus C3, and if n number of capacitors are connected in parallel, then the net capacitance will be C dash is equal to NC. Similarly, if the capacitors are in series, then the combination is 1 by C is 1 by C1, 1 by 2 C2 dot dot dot. That means the net capacitance in series decreases, net capacitance in parallel increases. Now if n capacitors are combined in series identical, then the C dash is equal to C by n. If two capacitors, C by 2, if three capacitors are connected in series, it will be C by 3. Now the formula of the parallel plate capacitor already you know, C is equal to epsilon 0, epsilon r, A by D. So epsilon r is the dielectric constant of the medium between the two plates of the capacitor. So these are the plate area A, plate separation D. So now accordingly the capacitance is epsilon 0, epsilon r, A by D. So now in the last video we have solved. These are the capacitors in combination. So now this is the there are 4 plates and different types of the arrangement. So we have already solved. So if you interested, please go and see video number 1. So you can able to understand. Next come to these are the problems we are going to solve today. Let us solve the problems now. So first problem. So in the same way, the technique I have told. So now this is the case of the capacitors. Now let us redraw here. Please everybody follow. So it is these are all interesting, easy. Once you will be getting, then you will think so capacitor parallel plate capacitor combination is very easy to work. So now these two plates are connected by the conductors. Now the terminals are A and terminals are B. So each plate has area A and each plate separation is D. So plate separation is D, area of each plate is A. That means capacitance of a capacitor is epsilon 0, epsilon r A. So if no air, if air is present in between, then the capacitance will be epsilon 0 A by D if it is filled with air. That we know because air has dielectric constant epsilon r approximately equal to 1. That already I told you. So now I have to find out, but question is, so it is a parallel or series. So you have to redraw and make it. Let's say the name of the plate is 1, this is 2, this is 3, this is 4. Now let us redraw them. So number 1 to 2, this is one capacitor, 1 to 2. So 2 is the combined, 2 is the common, and which makes capacitor 3. So I will take a common, the same 2, and it will make with capacitor. And C3 is common with 4, then it is equal to C3, then this is 4. Then plate A and plate B, so they are the end point. This is terminal A and this is your terminal B. One more thing, the plate 2 and 3 are connected by a conductor. So plate 2 and 3 are connected by a conductor. Yes. So how many capacitors? There are C capacitors, capacitance C, and capacitance of each capacitor is epsilon 0 A by D. That means they are air filled. So air filled capacitors. So now C is equal to epsilon 0 A by D. Now come to question here. Already I told you. So if two points are connected by a conductor, the potential of both the points are same. The potential of all the points are same in a conductor. And if a capacitor is connected like this, so this capacitor has no meaning. It will never be charged, because to charge a capacitor, potential difference is required across the plates. So this capacitor is meaningless. So if this capacitor is meaningless, let us redraw it and get the answer. So now the points are A and B. So this is the capacitor. This point is B, this point is A. From the point P, a capacitor is like this. and again it is coming to the like this. Now this is the point B. So these two capacitors are connected in one line. So both the capacitors are series. Combination of series is equal to C by 2 here. So if the capacitor in series, this will be C by 2. So that is equal to C by 2. So net capacitance between the point A and B is C by 2. That is 1 by 2 of epsilon 0 A by D. Look, this is the arrangement. This is the arrangement, and this is the capacitance. Epsilon 0 A by 2. So easy. Okay. All right. Now let us remove this one. Let us go to next one. So now you will find out any type of capacitor combination will coming. You can go with the same process. Name the plates 1, 2, 3, 4. Arrange the capacitance. Then see whether they are parallel or series. And sometimes there will be neither be parallel nor be series. That part is called Wheatstone bridge connection. That will be discussed in the next video. That is combination of capacitor, video number 3. That we will be going to discuss. Okay. Now come to question number. This problem is over. This part is over. Now come to next question. So in the next question, so now they are the connections are like this. So okay, 1, 2, 3, 4. That is 1. This is 2. This is 3. This is 4. And 1 and 3 they are connected by a wire. That is called short circuit. And this point is A. This point is B. So connected by a wire. Remember that is called short circuit. SHORT, short circuit, in short CKT, short circuit. If the two wires are connected by a wire, 2 points, they are called short circuit. As a result, the potential of these 2 points cannot be different. They are same. That is the important meaningful term here. So okay. Now proceed. Let us make the capacitor as usual. Now the 1 to 2, 1 2. Then it is equal to 2 3. Then it is equal to 3 4. So then we have to go fast. Now I think you are now able to understand quickly. Now 1 and 4 are 1 and 3 are connected. You connect 1 2 3. Then 2 is your terminal A. 3 is your which one? So now this is equal to 1 and 4 3 are yes connected. Then it is equal to terminals are given. Sorry, the terminals are given 1 and this is equal to 1 and this is the B. Okay, there is a mistake. So now this is equal to B. This point is B. Okay, this one. So 1 and 3. This is equal to 1, 2, 3, 4. So 1 and 3 are short circuited. 1 and 3 are short circuited. Then A is plate 2. Then B is equal to plate 4. Now this is the connection. Let us redraw them. So now this is the point A. Always redrawing is important, very important, must. So now this capacitor is connected from A. Let this point is equal to P. Now this capacitor is connected from A to P. So this capacitor, it is going from A then coming to P. So in between let us take a point P. Then it is A to P. So okay, this is A point. This is equal to P point. Again from A to P. So from A to P there are 2 capacitors. This one. From A to P there are 2 capacitors. This one and this one, they are A to P. Again from B to C there is 1 capacitor. This one. Now the arrangement is over. So if interested you can do like this also. That is equal to 2. From A it is equal to 2. From there it is equal to 1. Then from A it is 2. Then it is equal to 3. It is equal to 3. Then it is equal to 3. Then it is equal to 4. So if you rename, you can also get, when there is a question, find out the charge flow to each capacitor. Then you have to make the namings. Then you can understand how much charge is flowing to which capacitors. That you can able to follow or understand. Now these two capacitors are parallel. Now let us redraw it. Let us redraw always. That is 2C. This is C. Then again this becomes a single capacitor series. So I told you when two capacitors series, capacitance is C1 C2 by C1 plus C2, easy formula. Then I apply, that is net capacitance is equal to C dash is equal to 2C into C divided by 2C plus C, that is equal to 2C by 3. So the now final answer to the combination of capacitor is C dash is equal to 2 by 3 epsilon 0 A by D. This is the capacitance of the capacitor. This is the question number this. Please note down. Okay, please note down the capacitance. So the capacitor combination of the capacitor is equal to this much. Next come to next question, this one. Okay, so I am removing. Now you try to understand the concept of short circuit, how to rearrange the capacitors, and what is the basic formula of parallel combination, what is the basic formula of series combination. This is series combination, this is parallel combination. In parallel combination capacitance increases, in series combination capacitance decreases. So that idea you end, the capacitance of a parallel plate capacitor is epsilon 0, epsilon R, A by D. This much you remember. Then if by listening you can able to understand. So all type of capacitors I will be solving in three number of videos. One video that I have trained, now this is the 2, and 3 more good number of problems I will be solving. So now come to this one. So now this is all. By listening only 30 minutes, you can finish the combination capacitor. Only 30 minutes is enough. That is equal to 1, this is 2, this is 3, this is 4. 1, 2, 3, 4. Then 1 and 2 are short circuited. Then this is the 3 your terminal A, this is the terminal B. So now I am solving question number 3. So in this case, let us rearrange it again same way. Okay, in the same way let us rearrange. Now capacitor 1 to 2. Now first capacitor is from 1 to 2. Name it 1 to 2, 1 to 2. Then 2 to 3. Then 2 to 3. Then 3 to 4. Then 3 to 4. Then B is your one extreme point, and then 3 is another extreme point. Yes. So this is 4 is one extreme, and 3 is another extreme. So 3 is another extreme. This is equal to your A. Then 1 and 2 are connected. So 1 and 2 are connected. So we have to find out net capacitance between the point A and B. So look, net capacitance between the point A and B. So here this point is A, and this is the point B. There is a capacitor, and this is the B point, and behind the point A there are capacitors are there, and this capacitor to left has no meaning, because this capacitor is no way connected to A point, B point. So only one capacitor is in between A to B, that is equal to C. C is equal to epsilon 0 A by D. This is the net capacitance between the point A and B. So these are the capacitors, but they are not in between A and B. They are behind the 2 points A and B. So the net capacitance between A and B is this much. That is epsilon 0 A by D is the capacitance of this system. Okay. Question number 3 is over. Now come to question number 4. Here 5 plates I have taken. 1, 2, 3, 4, 5. Here I have taken 5 number of plates. Then I have to find out what is the net capacitance of the system. Look, same method. So now you can, I hope now you are in a position to solve by yourself, because many problems I have solved. The method is same, so I am not changing the method. Okay. Now let us start the problem number. This problem I am solving here. How many plates? 5 plates. Let us draw them here. That is equal to plate 1, 2, 3, 4, 5. 5 plates. 1, 2, 3, 4, 5. Plate 1 and 4 are short circuited. Plate 1 and 4 they are short circuited. Let us give them 1, 2, 3, 4, 5. Then 2 is terminal A. This is treated as terminal A. Then 3 and 5 are substituted. 3 and 5 are combinedly called as terminal B. So we have to find out net capacitance between the point A and B. So to find the net capacitance between A and B, so you know the practice, the way I have told many times. So let us start the practice. Okay, start. Point plate 1, plate 2, one capacitor. Let us draw plate 1 and plate 2. 1 and 2. Again 2 and 3, another capacitor. 2 and 3, another capacitor. Then 3 and 4, another capacitor. 3 and 4. Another capacitor between 4 and 5. So 4 and 5. 4 and 5. Now, if there are 5 plates, you know there can be 4 capacitors. Always remember, if the 5 plates are there, there will be 4 capacitors. 4 plates there, 3 capacitors. Like this. If there are n number of plates coming parallel to each other, then the capacitance will be n minus 1 numbers. So now here capacitors, the connection. 1 and 4, they are short circuited. Look, 1 and 4 are short circuited. This is 1, this is 4. So I have short circuited. 1 and 4, yes, 1 and 4 shorts only. Then 2 is terminal A. This point is A. This point is A. And 3 and 5 are connected. 3 and 5 are connected and they are called B. So if this is B, this point also B, this point also B, this point also B. So now this is point A, this is point B. Don't tell this is point B. So this is A, this is B. You tell now. This is B, this is B, this is B. So now this is A. Now you give any point. Let's say this point is P, this point is P, this point is P, this point. Only naming. Once it will be named properly, then things will be easier to think about it. Now the net external point, extreme points are A and B. So one point A, another point B. Same practice. Now let us follow. Now I am trying to look here. This is point A. This is point A. Another point is B. So again, in between A to B, so there is a point P also. That we have seen there is a point P also. A is a point, one extreme. B another extreme. So P is not extreme. In between anywhere you draw. So now in between anywhere I have drawn P. Let us go on connecting the capacitors and which will be connected. So let us put a tick mark. A to B. So A to P. A to P. This is A, this is P. A to P. There is a capacitors. Yes, I have connected. Put a tick mark. Over. Another 3 capacitors there. 1, 2, 3. How to connect? This capacitor is between A to B. Let us connect from A to B. This capacitor is from A to B. Listen again. A to B. Put. Another capacitor is from B. This capacitor is from this capacitor. This is from B to P. Look, this capacitor from B point to P point. Now this is B point. This is P point. Connect it. B point to P point. Connect. This capacitor is between B point and P point. Again connect it. Now all capacitors have capacitance C. Now how many capacitors? 1, 2, 3, 4. How many external points are? B and B. So this system is finally reduced to this one, which is a combination of parallel and series. You know the answer. So now you can get the answer quickly. What is the capacitance of this capacitor? Look. So now this part I am removing. This part is not necessary. All I will wait. So now anyway, so now this capacitance of the combination. This combination is equal to here. First one. These two are in parallel combination. Okay. These two are in parallel combination. The C plus C how much? 2C. Let us redraw again. So always redrawing is very important. Once you will be smart, then you can solve directly. A to P. This is A to P. A to P there is one capacitor. Yes, one capacitor C. Then from P to B, two capacitor parallel. So it will be C, 2C, because in your parallel this will be added. Then this point is B. Then from A to B directly there is a capacitor. Yes, there is a capacitor directly. B. Now 2C and C in series. If the two capacitors are in series, that way I told you. What is the formula? Two capacitor series. When two capacitor series, that is your C1 C2 by C1 plus C2 is the capacitance when capacitors are in series. So C1 C2. So one C is C, another C is equal to 2C. 2C divided by 2 plus 2C that is equal to 2c square by 3c, that is equal to 2 by 3c is the capacitance of these two. So these two now becomes 2c by 3. Now let us draw again. So this part is not required now. This part I am removing. So these two becomes how much? Now these two becomes a single capacitor series, that is 2 by 3c, and another capacitor is C connected between A and B. So what is the net capacitance between A and B? Yes, they are parallel. So the net capacitance or equivalent capacitance is equal to between A and B is equal to 2 by 3C plus C. Then net capacitance becomes how much? That is equal to 3 into 3 5. That is 5C by 3. So that is equal to 5 by 3 epsilon 0 A by D is the net capacitance between the two capacitors. This is all about the capacitance in combination. I hope you have enjoyed it. So if you like it, please subscribe and share it. Thank you.